Okay, illustrative math, unit 2, lesson 13 of algebra 2 is called polynomial division, part 2. Goal, I can divide polynomials by using long division. What do you notice? What do you wonder? Okay, take a minute, pause the screen, come up with some notices, come up with some wonders, okay? So, let's see here. What are some notices? What are some numbers? Okay, so it looks like these are long division. These are almost like steps of the long division. This would be the first step. 11 goes into 27 two times, and then you multiply 2 times 11 to get 22, and then you subtract 27 minus 22 to get 5. And this is the second step. I bring down the next number, this 7 right here. Bring that down. I repeat, 11 goes into 57 5 times completely, because 11 times 5 is 55. So I multiply that, and I subtract, and then I bring that number down to get here. So all this is repeat. 11 goes into 22 two times. You multiply, and then this is your remainder. Okay. Now, this is a polynomial here. So I wonder if I use the same steps to divide polynomials instead of whole numbers. So there's a notice. Using long division. Let's put a wonder down here. Wonder, can I use the same steps with a polynomial as with only numbers? Let's see here. I noticed that you see how many times x, or what you multiply x by to get 2x cubed. So I'd multiply x by 2x squared to get 2x cubed, and then I subtract. So that might be a notice here. The steps look very similar for polynomials. Here's a notice. I notice the coefficients of the polynomial are the same as the numbers above. So what I'm saying here is the 2 matches the 2. The 7 in front of the x squared matches the first 7. This 7 matches that 7, and then the 2 at the end matches the 2 at the end, okay? I wonder if, because these numbers match up, I wonder if I'm going to get the same number. I got the 2 here. I wonder if it's going to be 2, 5, 2. So maybe like, I wonder, is it going to be 5x plus 2? Okay, because I can't have another x squared because I'd combine those. So I wonder if that's going to be my final answer. All right, so good stuff there. Little review of long division. Okay, how many times does 11 go in? Then you multiply, subtract, and then bring down. All right, so let's look here. Diego used long division shown here to figure out that 6x squared minus 7x minus 5 equals 2x plus 1 times 3x minus 5. Show what it looked like if he used a diagram. So here's his long division. So here's how you do this. So I want to walk you through this. You start with this 2x and the 6x squared. Don't look at anything else. This stuff wouldn't be here. That's not going to be there. That's the work. So the problem would just be this. So you say 2x times what gives me 6x cubed? And the answer is 3x. Kind of just like you do here. 2x times what gives you 6x? I'm sorry, 6x squared. I'm sorry, 2x times what gives you 6x squared? Just like right here. So obviously the answer to that is, on the box, you'd say 3x, kind of like you put here. And then we multiply 3x times this whole thing. So 3x times 2x is 6x squared. 3x times 1 is 3x. But then you have to subtract, so we got to change the signs of both of those, okay? And then these cancel, and you add those, and we get negative 10x. Then I bring this down. And then I do it all over again. I'm only looking at the negative 10x and the 2x now. 2x times what gives me negative 10x? Well, that would be negative 5. And I multiply negative 5 times this whole binomial would give me negative 10x minus 5, but then I have to subtract. So I end up with two negatives on the 10x and two negatives on the over here on the 5. So they both become positive. Those cancel out. Those cancel out. There's my remainder. So if I were to finish this one, 3x times 1 would give me 3x. And then I got to say 3x plus what gives me negative 7x. And that would be negative 10x. And then 2x times what gives me negative 10x. This is kind of just like this step here. 2x times what number gives me negative 10x? And the answer is negative 5. And then we multiply here. And these are our factors. We have the 2x plus 1 times the 3x minus 5. Just like we have here, we could say the divisor times the quotient. All right. All right, so let's do this. I don't like how we did part of the steps here. So let's do this. I'm gonna get rid of this. And I'm just gonna start from scratch. Okay, so the only two things we're looking at here is the x right here, and the 2x cubed. So x times what gives me 2x cubed? Kind of like here, if I had x, and I have my box here, and I have the 2x cubed, just like we did here, x times what gives me 2x cubed? And you'd say 2x squared, right? Same idea here. And then I take this and I multiply it. Almost the same as if it was like Algebra 1 class. 2x squared times x minus 2. You distribute that, right? So you would get, whoops. You'd get 2x cubed minus 4x squared. But then you have to subtract, so I got to change both these signs. I'm following my long division steps. So here I get negative 3x squared, and then I bring down the x. And I do the whole thing over. So x times what would give me negative 3x squared? Well, the answer is going to be negative 3x. And then I subtract. So really when I subtract this whole thing, my signs change. So I like to put a negative outside sometimes. I see this is going to change to a positive and this is going to be a negative. So I'll just do it right here. I'll change it to a positive and to a negative. These cancel and I get negative 5x. And I bring down the next term, which is the 10. X times negative 5 would give me negative 5x. I'm only looking at the x and this first term. Don't look at the 10, don't look at the negative 2 until you start multiplying. Distribute negative 5 times x, negative 5x, negative 5 times negative 2, positive 10. Now I subtract, so I change these signs. This becomes a minus, that becomes a plus, and I get a remainder of 0. So what that means is x minus 2 times 2x squared minus 3x minus 5. If I multiply those, that gives me the 2x cubed minus 7x squared plus x plus 10. Okay, I'll try to kind of separate the problem from that. Cool, so I did finish this. I did not whoops, I did not write them as linear factors. This one's linear here, the x minus 2. This is quadratic, it's x squared. It doesn't say I have to take it down to linear factors. It just says get into x minus 2 times something. Okay, so there we go. That would be your answer. All right, so Jada used the diagram to figure out that 2x plus 1 times x squared plus 6x plus 5 is equal to this, the 2x cubed. So then let's try it with long division. So the only things we're looking at to start is the 2x and the 2x cubed. So this is just like here, 2x times what would give me 2x cubed? And the answer is 2x squared. Then I multiply this times the whole binomial. So 2x squared times 2x is, oh wait, no, that's wrong. That's wrong. It's because that would give me 4x cubed. It's just 1x squared, sorry. So x squared times 2x plus 1, all right? Just like if I wrote it here like this, all right? You distribute. So I get 2x cubed plus x squared, and then I change the sign. So I'm going to make these subtraction. All right, why do I change the sign? Because when you subtract, that's the same as changing the sign. So this would give me 12x squared. And then I bring down the next term, which is 16x. And then I do the whole thing, I repeat it. So basically, I'm only, oh, whoops. I was trying to click on that highlighted part, but I guess I'll just redo it. So I'm only looking at the 2x and the 12x squared here. So 2x times 6x would give me 12x squared. So I multiply, and then I do 6x times 1. Again, it's 6. You're thinking 6x times 2x plus 1. Okay, so it'd be 12x squared plus 6x. Subtract, so I change the signs to subtraction. It's a subtraction sign. Maybe I should just erase it. Those cancel and I get 10x. Bring down the 5. 2x times what gives me 10x? And the answer is 5. I get 10x plus 5. I change the signs and I get 0. So I get the same thing. I get the 2x plus 1 right here times x squared plus 6x plus 5. All right, here's some polynomial functions with known factors. Rewrite each polynomial as a product of linear factors using long division. Okay, so we did the first step for us. X times x squared will give us x cubed. And then you distribute x squared times x is x cubed. X squared times -7 is -7x squared. And then I change the signs to subtract, and that gives me both of these to cancel. Okay, so let's bring down the next two terms because I only have 2 left. So x times -16 will give me -16x. I multiply. And let's see here, -16 times -7 is positive 112. And then I change the signs. So everything cancels and I get down to 0. So what that tells me is x minus 7 times x squared minus 16 equals a of x. Now, it says this time we want linear factors. This one here is not linear. So I'm going to just do it the old way with the box because I already did long division. I put my -16 there, my x squared here. I say, okay, obviously x and x would give me x squared. And then -16, I need a 4 and a -4. Or maybe it was a 2 and an 8 or a 1 and a 16. But I know this is going to work because I want these to cancel out because I don't have a term with an x here. You see, I go x squared and then I don't have an x term. I want these to cancel. So I found the two factors here that make up the x squared minus 16. So the x minus 7 stays the same, and then this now becomes broken into these two. So and that's equal to a of x. Okay? All right. All right, let's go over here. Tell you what, I'm going to move this out of the way a little bit so I got enough room. All right, so I notice is that a typo? Should that be a minus 3x squared? Let me check your book. It is a minus 3x squared, so let me fix that. That is a typo on my end. Okay, so I'm going to start here with the x plus 3. I'll put the x cubed minus 3x squared minus 13x plus 15. If I skip any powers, I got to replace them with a 0 coefficient. So I look at the x and the x cubed and I say, okay, I need to multiply that by x squared. Now I wrote it over the x cubed. It might be better to write it on top of the squared so you keep everything lined up. And then I multiply or distribute. X squared times x is x cubed. X squared times 3 is 3x squared. Now I'm going to do it a little differently. When I subtract, I'm going to put in parentheses. Sometimes I like to do it that way. So that way it reminds me to just change the sign. It's a little neater. So x cubed minus x cubed cancels. Negative 3x squared minus 3x squared is going to give me negative 6x squared. Bring down the next term. X times negative 6x will give me negative 6x squared. And then I multiply, I get negative 6x squared minus 18x. Distribute this would be a plus 6x squared, so those cancel. This would be plus 18x, so that would be negative 13x plus 18x is 5x. Bring down the 15. X times 5 is 5x. Multiply. Subtract. And everything cancels. 5x minus 5x, 15 minus 15 gives you 0. Cool. So what I did was I got it down to x plus 3 times x squared minus 6x plus 5. So now I got to get this thing factored. So what I'm going to do is I'm going to go back to using the box method here. You could divide this into that to find one of the other factors, but it's a little bit more time consuming here. So I'll tell you what, that last box was really, really sloppy. So I'm going to make it a little neater here. So I'm going to put my x squared here and my 5 here. And I'm going to say, okay, x times x will give me that. And let's see here. I need to get negative 6x. So negative 5 times negative 1 still gives me positive 5 when I multiply those. And then when I multiply these add up to the negative 6x right there. So I can replace this as x minus 1 times x minus 5. And then I have the x plus 3. So this would be my final answer. Okay. All right, missing numbers. So let's see here. What goes in this blank? Well, look here. This is 14 here for your constant. So these numbers, the 2 times this would have to give me 14. So obviously 2 times 7 would give me 14. And then I could check it if I really wanted to. I could say x and 2, x and 7. That give me x squared, 2x, 7x, 14. Combine these two right here, the 2x and 7x, and I get x squared plus 9x plus 14. So the next one here, x squared plus 9x plus 20. So if I put a minus 4 and a minus 5, when I multiply these, I get the positive 20. But then when I add them up, I get negative 9x. So actually, that's not going to work because check this out, if I put x and negative 4, x and negative 5, I get x squared minus 5x minus 4x positive 20. That gives me a negative 9x. So I need these to be a minus negative 5 and a minus negative 4, which would eventually change these to, a plus 4 and a plus 5. But I'll just fill in the blank. All right, over here, on the next one, so again, there's another typo here on mine. You have a 2 here in front. Okay, so this negative 24 here, I need that to be numbers that multiply. These two multiply to give me negative 24. So, oh, you also have this filled in. You have that filled in. So I had a typo on here. So we need to get negative 24. So this times this needs to give us really negative 12 because I got the extra 2 to double it on the outside. So negative 3 times 4 right here would give me negative 12. But then when I multiply the whole thing by 2, I get the negative 24. This is my lead coefficient here. So really, if I multiply all the highest term coefficients here, so negative 1 times 2 times 1, that would give me negative 2. That would go right there. Let's see here. What number in front of x? So this comes from the 6x cubed. So it'd be x times 2x times something x equals 6x cubed. So 6x cubed equals x times 2x times something x. So there's my 3 x's, and I have a 2 here, so that'd have to be a 3x to give me the 6 in the front. All right, number 6. This time we have a couple blanks here. Starting to get a little trickier. So I need to get a negative 12 here. So I got a negative 3 here. So negative 3 times, let's just play around with some numbers here. Let's say 2, that give me negative 6, and then another 2. Is that possible? Is that right? Well, let's take a look here. Let's get all my x terms. So if I did 2x times 2, that would give me 4x. If I did negative 3 times x, that's negative 3x. If I do 2 times x, that's 2x. Oh, shoot, there's going to be a lot of these here. Okay, so this is going to be kind of tricky, actually. I might not be able to just do this in my head. So this one might be a little bit harder. I might not be able to just kind of match this up. So let's do this now for this. Number 6. Let's do a little division. We know one of the factors is 2x minus 3. So let's do what we were doing. 2x cubed plus 7x squared minus 7x minus 12. Let's divide by 2x minus 3. So 2x times x squared, and I guess I should write it on top of the x squared like I've been doing. Multiply 2x cubed minus 3x squared, and then I subtract. So those cancel. This becomes plus 3, so I get 10x squared. Bring down the negative 7x. I say 2x times 5x would give me the 10x squared, so I multiply 10x squared minus 15x, and I subtract. So 10x squared minus 10x squared cancels. Negative 7x, that becomes plus 15x, gives me 8x. bring down the negative 12. 2x times 4. So that'll give me 8x minus 12. Subtract the whole thing. 8x minus 8x, gone. Negative 12 ends up being plus 12. That's gone. I get 0. So, okay, now it's nice. I can do a box here and get this thing factored. So if I said, okay, x squared and 4, that's obviously x and x. This would be 4 times x would be 4x. This would be 1. 1 times 4 gives me 4. 1 times x is 1x. If I add these, I get that 5x. So there we go. A little bit more work on that one. Had to do some long division with my known factor, and then I had to make a box to get the other ones. And then this last one, I need the number in front of x. So, well, I could start here by looking at this negative 10. I'd need to multiply my constants. 2 times negative 1 times what equals negative 10? I'll just call it n. So negative 10 equals negative 2n. Divide by negative 2, I get 5. So that's helpful. So then what I would maybe do is maybe multiply all this out. So if I put my x plus 2 on the outside, if I make a box here, let me move all this. Whoops. If I make a box here to multiply x minus 1, x and 5, x squared, 5x, negative 5, negative x. So I get x squared plus 4x minus 5. So I multiplied these two here. And then I need to do another box here with the x plus 2 and the x squared plus 4x minus 5. So these are a little more work. The first ones we were kind of spoiled. They're pretty easy. So I really only need the x term. So if I combine these two right here, I end up with 3x. Okay, the negative 10 I already have. The 6x squared, which I already have, and then the x cubed I already have. So that one's going to be a 3. All right, a little more work on numbers 5 and 6, but good stuff there. All right, so use long division to find the quotient of 440 and 24. How many times does 24 go into 44 completely? That would be 1. I multiply, and then I subtract, and then I bring down the next digit. How many times does 24 go into 200? That would be 8. 8 times 24 is 192. And I subtract and I get a remainder of 8. So you could write 18 remainder 8. Okay, or you could say 18. You could put the 8 over the divisor, or the 18, I'm sorry, not 18, it'd be 8. 8 over 24, which would reduce as well. All right, let's do this one here. 2x plus 4 times 4x squared plus 4x. So 2x times 2x would give me 4x squared. I multiply now, I get 4x squared. When I do 2x times this whole thing, 2x times 4 would give me positive 8x, and then I subtract the entire binomial. So 4x, I forgot my squared there, sorry. 4x squared minus 4x squared is 0. 4x minus 8x is negative 4x. Okay, 2x times what gives you -4? That'd be negative 4x, that'd be -2. Multiply. Really, it's +0 here. -2 times 2x is -4x. I guess I could bring the 0 down. -8. So this becomes remainder of +8. So very similar to whole numbers, just now with polynomials. So goal, I can divide polynomials by using long division. I think so. All right. Let's take a look at this cooldown. Let the function p be defined by x cubed plus 10x squared minus 23x minus 132, where x plus 11 is a factor. So if you look here, here's my x plus 11. That's my factor. This is where the original polynomial goes. Okay. So let's see, where is the error? So I'm going to kind of follow through here. X times x squared would give me x cubed. I multiply, I get x cubed plus 11x squared. Here's the error. He needed to subtract this whole thing. I needed to kind of put parentheses here. So this is going to be minus, so it's going to be 10x squared minus 11x squared. So this should be a -1x squared right there. And then that will make the rest of this all wrong. Okay, so basically you had the x plus 11, and you had the x cubed plus 10x squared. So they said that the x times x squared, you multiply, you get x cubed plus 11x squared, and you need to subtract the whole thing. So it's going to be x cubed minus x cubed. Those cancel. 10x squared minus 11x squared would give me -1x squared. That's your error. Okay, so there's that. So, we have to finish the whole thing. So let me write it out here. Okay, so bring down the -23x. X times -1x would give me -1x squared. I multiply. I subtract. That cancels. This becomes plus 11, so I get -12x minus 132. X times -12, and then I multiply. Let me double check. 11 times 12. Yep, 132. And then I have to subtract this whole thing. So these cancel because it's plus. These cancel because it's plus. There's my remainder. So it's x plus 11 times x squared minus x minus 12. There's my product of two factors. So that would be 3. It doesn't say linear factors, so I don't have to make a box to get it down to linear factors. Okay. All right. Hope you enjoyed this video. Thank you for watching.